here. The cube root of x, right? That's okay. So far, so good? Okay. Then I replaced x by -3 the square root of 3. But if I replace it by -3 the square root of 3, I cannot simplify the radical. So what I did, I said, okay, let me put the 3 squared back inside. So negative the square root of 27 is the square root of 9 times the square root of 3. So that's how we get the -3 the square root of 3. So that's why we get this. Is this so far, is this okay? Yeah. Okay. Then I replaced it in here. And I said, when I take the cube root of a negative number, I get a negative number. So negative with negative will become positive. So now the cube root of the square root of 27. This is what we have to talk about, correct? Okay. So the cube root of the square root of 27 is the power rule. It's an exponential rule, power rule. We have to multiply the indices. And let me show you why we multiply the indices. So forget about the cube root for a moment. We know that this is 27 raised to 1/2, 1/2. But then I know that everything is has the cube root on top of it, but the cube root means power 1/3. And then I copy 27 and I multiply the exponents. And that's how we get the 6th root of 27. Now, how do I simplify this? I have the 6th root of 27, which is the 6th root of 3 to the 3rd. I copy 3, and now the power is 3/6. 3/6 is 1/2, which changes into the square root of 3. Is that better?
Yeah.
Perfect. Thank you. Is there anything else in here that we need to look at or we have questions on? Anything else?
I don't have one. I just have like another maybe chain rule one.
Yes, I'm ready.
We do something like
Yes.
What about like y equals x over the square root of x squared plus 1?
This one? To differentiate?
Yes.
Okay. Of course,
Chain rule, right?
of course I don't like it. Yes. You would have expected that. You know I'm not going to differentiate something like this when I have to differentiate the square root of x squared plus 1 in the numerator, blah, blah, blah. Of course not. Eventually I'll go back and I'll simplify with no negative exponents, but for now, I would definitely prefer this versus that.
Yeah.
Okay, so then I differentiate as a product. This is function 1 and this is function 2. So dy over dx has to be a sum of 2 terms because we are using the product rule. The first function prime is 1. So then we have x squared plus 1 to negative 1/2. And then we have x, and now I have to be very careful. Careful because the power is negative, etc., etc. We bring the power in front. Please put parentheses because we have a multiplication symbol and a negative symbol, and they have to be separated using parentheses. So I bring down negative 1/2. I subtract 1 from the power. Negative 1/2 minus 1 is negative 3/2. But now I have to multiply by the inner function front. And you know I'm going to run out of room, but this time maybe not. 2x. Is this clear so far? Everyone? We can leave negative exponents in the final answer, so it needs work. However, I still believe that it's easier than if you use the quotient rule on this. It's just a personal preference. You are going to develop your own preference or your own style, I'm sure. Of course, I'm going to do this immediately because I multiply negative 1/2 by 2. So then, for now, I have dy over dx as being 1 over the square root of x squared plus 1. I have minus. I have x squared at the top because I have an x squared. I have an x here. I have negative that I have to put in front. And I want us to talk a little bit about this x squared plus 1 to negative 3/2 so we can get a grasp of it on it. So if it's negative 3/2, then I have a whole integer and the square root. Let me explain what I'm saying. I'll come back. So if I have x to 1/2, that's the square root of x, no one can do anything to it. But if I have x to 3/2, it will save us a lot of time if we see this. This is x the square root of x. How come? X to the first power times x to 1/2 is x to 3/2. We're going to save a lot of time if we try to understand and remember, not memorize, but remember that x to 3/2 is a full x and the square root of x. That's always for power 3/2. Now, if I have power 5/2, I even like that even more, because then I have x squared the square root of x. It's 4 over 2, which is 2 full integers, right? 2 integers and 1/2. So here I have 1 integer and 1/2. So does it make any sense?
Can you write it
Yes.
like 5?
1 and 1/2. Copy the base, add the exponents. 1 plus 1/2 is 3/2.
Well, could you
Yes.
write,
So 5/2 is 4 over 2 plus 1/2. 4 over 2 is power 2, and 1/2 is power square root.
well, no, I'm saying, like how you have like the little 5, the square root, x.
Yes, yes. So it's the square root of x to the 5th, which is the square root of x to the 4th times the square root of x. And that's how you get x squared, and that's how you get the square root of x, if it's better for you.
So what if that exponent was on the left side? Like,
Say it again.
if it was like in that little crevice,
Here.
so it'd look like 5, like that.
You mean the 5th root of x squared?
Yep.
We cannot do anything.
Well,
Very
no,
good.
how would you write that as a,
I can't. So here's the answer. If the power is smaller than the index, you can't simplify. It's carved in stone. You can't do anything to it. I can only manipulate the expression as long as the power is higher than the index.
I gotcha.
But if I have 5 and 2, nothing. I
So,
can't touch it.
so if you were to write that one as a fraction, it'd be x 5 over 2.
Yep.
Okay.
2 over, yes, this is 5 over 2. This
Yeah.
is 5 over 2. But the 5th root of x squared, no one can do anything to. Because this cannot be further simplified. I cannot take any integers, whole expressions out of the radical. That's what I mean. It's only when the power is greater than the index.
Okay.
So that's why this one is 3/2, greater, a full x and a square root of x. This one has 2 full x's and a square root of x. 7/2 will be 3 full x's and the square root of x. But 2/3, nothing. 2/5, nothing. So coming back here, it will save us a tremendous amount of time understanding that this is x squared plus 1 times the square root of x squared plus 1. Only because the power is 3 over 2. It's negative, so I have to bring it to the denominator also. But it's power 3 over 2. A full quantity plus a square root of the quantity. It can be x, it can be x squared plus 1. Why is this so important? Because now if I see it like this, I know what the least common denominator is, and I know exactly what this quantity needs to be multiplied by. What does it need to be multiplied by?
X squared.
What it does not have. But if I don't have it simplified, it will be more difficult to deal with it. I still believe that my students learn algebra from me as well. It's my pride and joy. Nobody does that. I've still to see it in any place. Okay, so then this one needs an x squared plus 1, which I like very much. Look at that. So x squared plus 1 minus x squared, the numerator is 1, the denominator is that, and I'm done. So dy over dx. So please remember this. It's not difficult, and moving forward, you will save you a lot of time. And of course, only when the power is greater than the index. Otherwise, there's nothing we can do about it. How do you feel about this one? A little bit better? Yes? Okay, so I would like us now to start 3.7, sorry. Yes, I know. I have to move on. I haven't done anything. I was lazy today. Didn't do anything.
Sorry, I didn't mean to go on
Didn't
a
teach you.
tangent.
No, that's fine. I mean, I have to answer questions.
A lot better will be working on, so.
Of course. I mean, as I said, if I don't have communication with my students, I get very worried. And I wake up in the middle of the night and sometimes I'm like, are they studying? Do they understand what I'm doing? Okay, 3.7. Rates of change in different applications. So I'm just going to call it applications. Of course, of differentiation. Applications of differentiation. Let's start with a very simple situation. I'm sure you're going to like this one. And it's an easy one, very easy to understand. Everything easy here, like a motion situation. So let me. Okay, so just read any of these 3 problems on motion and choose one.
No, 11.
No, we're talking about motion, 8, 9, and 10. I guess this is nothing, we are just,
So we're doing 10.
10, fine, okay, sorry, I was reading what you were reading, so. Okay, so we want to start with 10 on 234. We are given a particle's motion. It should be s of t. T to the 4th minus 4t cubed minus 20t squared and plus 20t. Of course, time is greater than or equal to 0. At what time does the particle have a velocity of 20 meters per second? And part B, so I can put the book aside. At what time is the acceleration 0? And what is the significance of this value of t? Okay. So I'm asked to determine when is the velocity 20 meters per second. What do I have to determine first?
The velocity is
Correct.
first derivative.
Yes. So in part A, the velocity of t is indeed s prime of t. Can anyone give us the s prime of t?
Or t to the 3
Yes?
minus 12t to the square
Yes?
minus 40t plus 20.
That's it. And now we're asked to find when is the velocity 20 meters per second. What do I need to do next?
Okay, 20. Wait, what was the question?
When is the velocity 20?
Set it equal to 20.
Perfect. So 4t cubed minus 12t squared minus 40t plus 20 equals 20. This is really nice. And of course, I am going to divide for sure by, not by t ever, but by, good. So t cubed minus 3t squared minus 10t equals 0. Of course, I will factor out, by the way, how many solutions will this equation have? Real, imaginary, I don't care. Exactly 3 because the degree is 3. It's a polynomial equation. 3 degree 3 solutions. Of course, I will factor out t, and I get t squared minus 3t minus 10. And of course, I will factor, hopefully I can, t squared minus 3t minus 10. So then t, and then I will present 3 solutions. So how will I factor the inside?
Should be t minus 5. T plus 3.
Awesome. So I have 3 solutions. Can anyone give us 3 solutions?
Zero, 2, and 5.
Not acceptable because a time is greater than or equal to 0. So this is at time 0 seconds and this is at time 5 seconds. The velocity is 20 meters per second. Part B. We're asked to determine the time when the acceleration is 0. How do I determine the time where the acceleration is 0? Right. So in part B, I have to find the acceleration and set it equal to 0. Can anyone give us the expression for the acceleration function?
It's the double plane.
Yes. So the acceleration is the first derivative of the velocity or the second derivative of the distance. But since we already have the velocity, we're going to differentiate the velocity. And we get,
12.
very good, 12t squared
Minus
24t, and indeed. So this is the acceleration function, and we want to set it equal to 0. So then we have 12t squared minus 24t minus 40 equals 0. Yes, you know what I'm going to do first. I refuse to work with these numbers.
Divide by t. I mean, 4.
Divide by 4, very good. So then we have 3t squared minus 6t minus 10 equals 0. 3 and 10, negative 30, and negative 6. I can, so I have to use the quadratic formula. So t equals negative b plus or minus the square root b squared minus 4ac over 2a. This is a refresher on the quadratic formula. So then t equals negative b plus or minus b squared minus 4 times a times c, which is negative 10. I don't like nested parentheses, so I'm going to change this into positive, over 2a. So negative 4 from the formula, a is 3, but c is negative 10. Instead of writing negative 10, I change this symbol into positive. So allow me to show you, I'm sure you do know, but maybe not. So allow me to show you how I plug this in the graphing calculator. Ready? Yes?
I know, I'm just writing it.
Yeah, I'm waiting.
4 times 3 times 10.
Yes, so it's negative 4 times a, which is 3, times c, which is negative 10. Instead of writing negative 10 and having the negative here, I change it into positive. It's even easier to plug it in the calculator. Ready? Okay. Why do I turn this off? But there's no way. Okay, so here it is. Parenthesis, oh, I forgot to say. So please put parentheses around the numerator always. And if you have in the denominator more than one term, if you have two terms, then put parentheses also. If you have one term, you can get away without it, without parentheses in the denominator. So left parenthesis 6 plus square root. You know me, I don't care. I will always put parentheses under the square root, no matter what the software says. 4 times 3 is 12 times 10 is 120. I can do that. Get outside of the square root, close the parenthesis, and divide by 6. Then you don't have to type this back in. Just go to second and entry. The calculator will bring it up again and go over plus and change it into minus. It's so much more, it takes me more time to do it here. So override plus into a minus to get the other solution. Of course, I'm not going to consider that one because it's a negative solution for time. So t equals 3.08 seconds, and t equals, algebraically, this is correct, 0.82 if you want, but it makes no sense. This is nothing, and this is correct. So what does this time mean? We're going to talk a lot about this idea in the next chapter, but what does that mean? So here's the velocity function. Where is the acceleration 0?
Points to the left.
After it's already thrown.
When the velocity is?
Zero when it's peaked.
Exactly. When it's either maximum velocity or minimum velocity, right? So it has to, so the previous function of, this is the derivative of the previous function. So the acceleration is the derivative of the velocity. So where velocity has a peak, that's where the acceleration is 0. Good. Moving on, I'd like to talk about a different topic. Let's read it. The cost function for production of a commodity, either 31 or 32. This is in social sciences. It's a very well-known topic. Find the marginal cost, find the cost, the derivative at 200, compare the derivative at 200 with the cost of manufacturing, blah, blah, blah. So please choose 31. 31 has 3 parts, 32 has only 2. I think we should go with 31, if that's okay with you. Yep, good. So 31. We're talking about marginal cost and the meaning of the marginal cost. Marginal cost, ready? Okay, 31 on page 236. The cost in dollars of producing X yards of a certain fabric. So X is in yards. Is C of X equals 1200 plus 12X minus 0.1 X squared. Am I copying something else?
No, you
I'm-
can't see it.
Oh, I'm very good at that. And at copying something else too. It's not my only flaw. 5 X cubed. Keep an eye on that because sometimes my glasses, because I normally don't read with glasses, as you probably saw. But these glasses are for distance, and when the book is so close to me, they're blurry. What I see is blurry, so please help me with that. No excuse though. My glasses are too strong for such a short distance. Okay, very good. So this is the cost function. Of course, I don't like it. 0.00. Are there 3 zeros or 4 zeros?
3.
3 zeros. Okay, thank you. So 5 x cubed minus 0.1 x squared plus 12x plus 1200. Of course, they are intentionally giving us the function twisted like that and not in descending order. It's not that it's such a big deal, but it's a habit of mine. I prefer all functions to be in descending order. No negative leading coefficient is possible. When I solve equations, I always simplify first. You already know my style. You make up your own style from what you see and what you learn from here or other places. Okay. First question, part A. Find the marginal cost function. The marginal cost function is c prime of x. So the derivative of the cost is called marginal cost. The rate of change of the cost is called marginal cost. So very easily, c prime of x is 0.0015 x squared minus 0.2x and plus 12. So this is the marginal cost function. I differentiated the cost function, the rate of change of cost at any point for any number of units manufactured. This is a polynomial function. It doesn't have corners, cusps, vertical tangents, so it's differentiable everywhere. There's no discussion on that. In part B, find c prime of 200 and explain its meaning and what does it predict. So for now, I would prefer putting this function as well as the original function in the graphing calculator, and you'll see in a minute why. So let's go to y equals. Clear if you have anything in there. So I would like to put the function first. 0.305 x to the third. And then minus 0.1 x squared. And then plus 12x and plus 1200.
You forgot minus.
Of course I did. Thank you. I clicked on it, but it doesn't. You have to give it time. And I probably didn't. Thank you. Thank you for keeping an eye on that. Plus 1200. And then the derivative also, I'd like to have it in there. 0.0015 x squared minus 0.2x. And then plus 12. Of course, I have to go back into table set, because as you know, it's always going back to the default. And at this time, I'm only asked to find c prime of 200. Let's analyze what c prime of 200 represents, first of all, before I plug it in. What is the meaning of c prime of 200? When we manufacture 200 yards of fabric, how fast is the cost changing per yard? Remember, the measurement unit for a rate of change consists of two measurement units, one for the top and one for the bottom. The top is the cost, the y function is the cost, and the x, the independent variable, is number of yards. So c prime of 200 will represent how fast is the cost function changing per yard when we manufacture 200 yards of fabric.
So it's cost over yards.
Yes,
For instance.
dollars per yard, the rate of change, yes. Do not look at the first function. I don't care for the first function right now. I care about the second function, which is the derivative. So c prime of 200 is $32 per yard when we manufacture 200 yards. And this is important, and this amount, it predicts the cost of manufacturing the 201st yard of fabric. It predicts the cost of the next yard of fabric, the 201st. Is there a way of determining the exact cost of the 201st yard of fabric? Is there a way of determining that? Exactly. This one is a prediction. This one is not exact. It's a prediction. But is there a way of determining the exact cost for manufacturing the 201st, the exact 1 yard, the 201st yard of fabric? Is there a way?
Maybe you just add 32. No.
Okay. I pay $10 for 5 cakes. And I pay $12 for 6 cakes. How much did I pay for the 6th cake?
$7.
One more time. I paid $10 for 5 cakes. I paid $12 for 6 cakes. How much did I pay for the 6th cake? How did I determine that? From 12, I subtracted.
6. Sorry.
I subtracted
10.
10, right? From $12 for 6 cakes, I subtracted $10 for 5 cakes, and I know how much I paid for the 6th one.
Could you do the same thing, just divide by 12 from 6?
Right, but it could be different.
Oh,
Price could be different. How do I determine the exact cost of the 201st yard, just that yard?
So you divide.
Subtract the 201st,
From the cost of manufacturing
200.
and 1, from the cost of paying for 6, I subtract the cost for paying for
200.
for
Like-
5. Exactly.
I see.
So the exact cost for manufacturing the 201st yard, again, who can tell us again how to write this? The cost of 201 minus, exactly. And let's see how close we get to 32. Back to our calculator. I want 201. Can anyone tell us what is the cost for manufacturing 201 yards?
0.402.
201 yards is the
Oh, it's
cost for manufacturing.
32.2.
The cost for manufacturing 201 is 3,632.20. The cost for manufacturing 200 yards is 3,600. Therefore, the cost for manufacturing the exact that unit, this is not going to happen again. If you want to determine how much you pay for the 301st yard, the price is not going to be the same with 32. Because f of 301 minus f of 300 is not going to be the same with f of 201 minus f of 200. So we're talking specifically for the 201st item. So it would be 32.2. So let's write, to be exact, I will go up and copy this whole thing. So C of 201, the cost of 201 is 3632.2005 and minus 3600. And the answer is exactly 32.2005. So this is the exact cost for manufacturing the 201st item. Now, what do you think about the derivative evaluated at 200? Is this answer, that over there, 32, is that answer for you close enough to this exact? Yes, it is. Now, if it's a life-threatening situation and medication or something like that, you may say, no. The 0.2 is a huge error for me. I'm not going to use this. I want to use this. But in general, it's a very, very good approximation. So what did we just do? We approximated the cost for manufacturing one particular item, one unit of that item, I should say. We approximated using the derivative. Yes?
So why is it, so say I just plugged in the 300 and 301.
Yes.
And the difference is like 87.4.
Right. So here's why. Because the cost function is a cubic function. Depending on where you are. Depending on where you are, the slope of the tangent will be different. It can even be negative.
Well, no, I wasn't sure why it was like why wouldn't it be 9,300, say 32.
So you plugged in, let me see if maybe I misunderstood your question. So you're saying that you plugged in 301.
Or I plugged 300 and then I plugged 301.
So 300 and 301. Right. So it depends on where you are on the function. So for example, very good question. So this is our function. It has a positive leading coefficient. It's cubic. So it looks like this. I'm just graphing a cubic function that is that has a positive leading coefficient. I didn't find the x-intercepts. I don't know anything about that. But I just graphed a function that is it's cubic function with a positive leading coefficient. See here, let's say this is 200 and this is 201. So this is the slope. But look here. The slope is much higher. And look here. The slope is negative. So the cost for manufacturing the next unit will be a negative, will subtract from.
So it's kind of like buying in bulk.
It depends. It depends on where you are on the function, yes.
So like if you were to only buy 50, to buy the first one, it might be more
Yes.
than buying 300.
Yes. Normally when you order in bulk, for example, you order 10,000, the price per unit would be one thing, but this is different. We're talking about the rate of change of cost. But you understand what I'm
Yeah, I
saying.
see what you mean.
But per unit, if you buy 10,000, it would be much smaller than if you buy 200.
Cool.
Yeah. Final question here. We have part C. I know I have one more minute. Compare C prime of 200. C prime of 200. We are comparing C prime of 200 with the cost of manufacturing the 201st yard. So this was a 32 per yard. And the other one, we were going to call it delta C, the exact. So this is C of X plus a little bit. I know we're going to go back to that. I have no choice. I know this is our first best friend, right? So this is 32.005. So please 2005. So please compare. What would you say? Pretty darn good. Pretty close.